Hmm? Okay, so we will be looking at paper 1 2014, right? And the first question, they give you the number 3.14063, and they want us to write it to 3 decimal places. Now, what you'd realize is as you do more and more papers, you would see more and more questions repeating themselves. I think this question was also in 2012 paper that we did on the last occasion. All right, so right here, right, 3.14063, I wrote it back here, and they wanted it to 3 decimal places. So from the decimal point, you go to the third place, which is 1, 2, 3. And at this point where the 0 is, we are going to stop there, but we need to look at the digit to the right. And if that digit is 5 or more, then this digit, the 0, would have to go up by 1. So the 6 is 5 or more. It's actually more than 5. So this 0 goes up to 1. So the answer is 3.141, which corresponds to answer B. All right. The next one, 4.3 by 0.37. They give you that as 1.591. So I wrote it here. Given that 4.3 times 0.37 is 1.591, that's our starting position. They want us to find this product here, which is 0.43 by 370. Now, we have to use this information here to help us solve this question. So how is 0.43 related to 4.3? Right? What's the relationship between that? Well, 0.43 is really 4.3, right, divided by 10, because that would cause this point to come here to give us 0.43. So if we took 4.3 and divided it by 10, we'll get 0.43. So this could be replaced by this. Then, what's the relationship between these two? Well, if I take 0.37 and multiply it by 1,000, 1, 2, 3, I'll get 370. So 370 is the same thing as 0.37 times 1,000. So now, the 4.3 times the 0.37, we could put it here, write it back down. And this 1,000, we could divide it by this 10 here, like this. And then that would result in this product, 4.3 by 0.37, which was given up here as 1.591. So we're going to take this and replace it by 1.591. And when we multiply it by 1,000 over 10, well, if you divide it through, you'll get the 0 canceling with this 0 because you divide the top and bottom by 10. So it ends up simply being multiplied by 100, which is this 100 here. So when I multiply 1.591 by 100, I simply move the point here 2 places to the right, 1, 2. So I end up with 159.1. And that was actually option B. If we look here, oh, sorry, that's actually option C, 159.1. So let me just change that to option C and not option B. So this is C, right? And C. Okay, so it's 159.1, right? And not 15.91. So the answer is 159.1, option C. The next one we're looking at is number 3, 5 2/5 plus 4 3/5. There are multiple ways, but I chose to do it this way where I added the 5 and the 4, which is this, and then the 2/5 and the 3/7. So I got the LCM of these two numbers as 35, and then I said 5 into 35 is 7, 7 times 2 is 14, plus, which is this plus here, 7 into 35 is 5, 5 times 3 is 15, 14 and 15 gives me 29 over 35. So this part gives us 9, and this part here gives us 29 over 35. So we have to add the 9 onto the 29 over 35. The answer will give us 9 and 29 over 35. So that was actually D. This one here, 9 and 29 over 35. Next one, written correct to 2 significant figures. Well, let's look at what we have available without doing any major calculation. Instead, without multiplying this out, there's a way to do the calculation without actually going here and doing the multiplication by using elimination. So look at this technique here. right? This number here is not to two significant figures, and they wanted the answer to two significant figures. So any answer here that is not to two significant figures cannot be considered. So this one is the four significant figures, 1, 2, 3, 4. So if it's four significant figures, the x here means we cannot consider it because they want the answer to 2. This one here is also, well, it's actually 1, 2, 3, 4 significant. I had 3, but it's actually 4. So let's fix that, right? If the zero was anywhere else, if the zero was up in front, it's not considered to be significant, but it could be anything other than the first. So it's considered to be significant here. So this is not 3, it's actually 4. 1, 2, 3, 4. The zero is considered to be significant. So I'm going to put it in as 4 significant figures there. So again, that is not satisfying the fact that it has to be 2. So that's not going to be considered also. Right? The next thing we have to look at is these two. These two are too significant because the zero is not significant, as zero could never be the first significant, meaning that this and this would be significant now. And there are only two here, right? None of them is zero, so both of them are significant. So these two fall into the criteria. But if you look at this answer, it's too small because if you're multiplying 18 by 2.0 something, right? 18.96 by 2.0 something, it could never give you a decimal. It has to be more than a decimal. So without even multiplying, you know, it has to be this as the answer right away, right? And even if we look at 18 alone by 2, that's about 36, which is kind of close to 38, with the 38 difference being caused by it's not actually 18, but 18.96. So that will give you the increase to give you the 38 value, right? When we round it off to two significant figures. So the answer here has to be answer B. All right, so we'll move on shortly to the next one. And the next one deals with shares, right? It deals with shares. And we have done a lot of work on that. We're going to use something called the unitary method to solve this particular question. So in this one, they said if 350 is shared in the ratio 2 to 5, like here, the smaller share is. Okay, well, the total shares, if it's 2 to 5, will be 2 and 5, which is 7 shares, or 7 parts, any one you want to, or 7 units. And if 7 shares is equivalent to $350, because that's the total to be shared, then one share will be 350 over 7, which is $50. The smaller share is 2, out of the 2 and the 5 is 2. And if one share is 50, then 2 shares will be 2 times 50, which is 100. And that corresponded to answer C. So the answer in this case was answer C. All right, next one. In a school, the ratio of the number of pupils to the number of teachers is 20 to 1. So I wrote down pupils to teachers, P to T, 20 to 1. Right? So the relationship between parents, pupils, and teachers is that the pupils is always 20 times the number of teachers, or vice versa. To get the number of teachers, we divide the number of pupils by 20, and we get the number of teachers required. All right. Now, the number of pupils here was 840. So with this ratio of 20 to 1, to get the number of teachers, we simply divide 840 by 20, and we'll get 42, which is answer B. Now, of course, you must be able to do this canceling down and end up with your 42, right? So no calculator. So you must be able to do that. So make sure and practice it, doing it without your calculator. So that was answer B. In number 7, if 3n is an odd number, which of the following is an even number? Well, we are saying that the answer is A, because once you have an odd number, which is represented by this 3n, to get an even number, you either have to add 1 or subtract 1 from an odd number. So take, for example, I choose the odd number 3, right? If I write down all of these here as odd numbers, right? And what I'll show you is that I'll get even numbers when I take away 1 from the odd number. So for example, if it was 3, right? and I wanted to create an even number, I could subtract 1 from it. 3 take away 1 is 2, right? Odd number 5 take away 1 will give me an even number 4. Next, a random odd number 13 take away 1 will give me an even number 12. Also, if we had added 1 in each case, we would also create an even number. So this is how you can get it. And similarly, if you have an even number and you add or subtract 1 from it, you will get back an odd number. Okay, so the answer here was actually E, right? This one. Take the odd number, which they said was 3n, and just subtract 1 from it, and you'll always get even numbers. So that's 7. Let's go to 8. What is the highest common factor of the set of numbers 54, 72, and 90? Okay, now these cannot be common factors because this number cannot go into any one of these. 90 could only go into 90. It cannot go into 72 and 54 because it's larger than those, so it cannot be a factor. 9 could go into these, I'm sure, because we know our 9 times table. 9 into 54 is 6, into 72 is 8, and into 90 is 10. So we know this for sure. But what about this guy here? 18 might be, so that I put a tick by it. But let's see if it really is. Let's see if 18 are actually factors. So I came across here and I said 18 into 54. I got 3 because 18 by 3 gives me 54. So 18 into 54 is 3. 18 into 72, we're looking to see if 18 is a factor of 72. I realized that 18 times 4 is 72, so 18 into 72 would be 4. And 18 into 90, I realized 18 times 5 is 90, so 18 into 90 is 5. So yes, 18 is a factor of 90, so I'm going to tick it. Not only 90, but all 3 of them, so I'm going to put a tick. But which one of these 2 factors would be the highest common factor of all of them, right? And obviously 18 is larger than 9, so 18 would be the highest common factor in this, right? It'll actually be higher common factor because it's only 2 of them are factors, right? Of all of them. So 2 of them are common factors of all of them. So the answer there is B. Okay, so B. In number 9, 99 by 101. This is an error here. That's not supposed to be there as a photocopy mistake. It's really 99 times 101. So which one of these is that? Well, 99 times 101 is the same thing as 99 times 100 plus 1, because 101 is 100 plus 1. But then if we use the distributive law, what the distributive law says is that we multiply the 99 by the 100 and the 99 by the 1. So 99 times 100 would give me 99 times 100 would give me this, and 99 times 1 will give me this. And that, if you look here, is option C, which is this one here. Okay, so this is the answer for number 9. Number 10, the first 3 common multiples of 3, 4, and 6. Well, we did this in the last class, right? But I wrote down the first 3 common multiples, right? So it would be 3 by 4, right? That'll be the multiple of 3. 4 now would be the second one here, 4 by 3, and 6 by 2. That first common multiple of all of 3, 4, and 6 would be 12, right? So we're looking at, let's see what we're looking at. We're looking at 3, we're looking at 4, and we're looking at 6. And when we multiply those out, we find that the first common multiple of those 3, 4, and 6 would be 12. We're looking at 3 again, 4 again, and 6. What is the next common multiple? We say that that'll be 24 because 3 by 8, 4 by 6, and 6 by 4 will give us 24, which is the next higher common multiple. And then if we take 3 again, 3, 4, and 6 is what we're looking at. 3 by 12, 4 by 9, and 6 by 6 all give us 36. So these 3 numbers here would be the first 3 common multiples. There will be other common multiples, right, of 3, 4, and 6, but the first 3 common multiples will be 12, 24, and 36. We did it all in more detail in the last one, so you could always go back to 2012, paper 1, which is loaded up onto the YouTube channel, and you will be able to see the more in-depth, longer explanation. But the answer, of course, is D in this case. In this one, number 11, they give you P, Q, and S. And they say then P intersect Q intersect S. What does that mean? What element or elements are common to P, Q, and S? Or what number or numbers are in all three of the sets? And the only number that is in all three of them is the number 2. So that would be option A, right? So that's why we put A there, right? The only common one was the 2. We could put that to show you. Okay, so let's go to the next one. Item 12, which is this here, it refers to the Venn diagram below. So this refers to here. Now, when they gave us the Venn diagram, it didn't have any writing in it. It just had P with this intersection and Q, and nothing was inside of here. It was a plain circle with nothing in there. I wrote in these numbers and X, right? Because there's a standard way that you could approach this. And then somebody gave me a formula. I think it was Javon Small. Javon gave me a formula that I also put here for you to have a look at. But the standard way that we work it out, these questions out, would be to, once we don't have a value for the intersection, we will put X to represent that value, okay? So in the Venn diagram, the number of elements in P was 5, Q, 9, and in the union, P union Q was 10. Now, if they had said P only was 5, I would have put 5 right here, and Q only, I would have put 9 here. But they didn't say that. They said the number of elements in P. So that means 5 had to take care of this area and this area. So that would be P only and also the intersection, right? Now, if I call the number of elements in the intersection X, and they had to add 5 in this whole circle, then in P only, which is right here, it would have to be 5 take away X. Similarly, if Q, which is the whole circle here, would have been 9, and there were X in here, then to get in Q only, which is right here, would be 9 take away X. Right? So we have to always remember that. In your multiple choice, they might say the number of elements in Q only was 9, right? And you guys have to know how to write that. I'm going to write Q only here for you, just as a point. Let's say, just so that you'll know, Q only, right, will be the number of elements in P and not Q, right? That means Q only. So if they had told you this, N, open brackets, P intersect Q complement, close brackets, this means Q only was 9. If they had told you that that was 9, then you would put 9 here alone, right? So you have to be able to recognize that, otherwise you will end up in a little problem, okay? So I'll just put an asterisk because it really doesn't apply here. It's just added information I'm giving you. So how would we work it out? Well, if they told us that the number of elements in the union was 10, then that means that this area, which is P only, P and Q only, if we add all of them up, we're supposed to get 10, right? So that's what I did. I put 10 as the union would be this area, 5 minus X, which is this, plus this one, X, which is that, and then 9 minus X, which is that. If we add all of that, we're supposed to get 10. So we're just going to solve that equation. The minus X and the plus X, they cancel out. And then this 5 and this 9 add up together to give us 14. And then we just have this minus X here. So 10 is going to be equal to 14 minus X. And therefore, X is going to be 14 take away 10, right? You're supposed to know to manipulate the equation to get the correct value of X. And that worked out to be 4, which is item B. Right? Now, another student showed me this formula, right? And it's just a formula, so it could be tricky. But when there's nothing outside here, this formula would apply, right? It says that the number of elements in the union of these two sets is equal to the number of elements in P plus number of elements in Q minus the intersection. So he showed me this formula, and I checked it against this, and it worked out to be correct. So I'm just alerting you to that. So when you don't have anything out there, if you memorize this, you could use it. And so when we fill in the information, 10 for the union, 5 for the number of elements in P, and 9 for those in Q, take away the unknown, which is the intersection that they want, Q and P, or P and Q is the same thing, then it comes down to this formula. 9 and 5 and 9 is 14, and therefore to get this, you manipulate the equation and you get the same answer as 4, which was option B, right? So that's another bit of information you could take note of. In this question here, they give you the Venn diagram. You were those who played games. That's everybody playing games here. Those who play hockey was in this circle here. Those who played volleyball in this one, right? And there were 3 people who didn't play either hockey or volleyball. So they wanted to know the number of students in each set. Well, it's shown, they told you how many students do not play volleyball. Now, if you look at this, this would represent the people who play volleyball in the circle. That'll be the 2 and the 4. So those persons who don't play volleyball will be outside of the volleyball circle. They would be these guys here and these guys here. So that'll be 5 and 3. And 5 and 3 will give us 8. So that's correspond to item D. So 8 people play do not play volleyball, right? Those who do not play volleyball will be 8, and that's item D. In number 14, all students in a class play Scrabble or checkers or both, right? So I drew Scrabble, I drew checkers, right? And those who play both would fit in here. This section here would be those who play Scrabble only, and this section here would be those who played checkers only. This section will be those who play Scrabble and checkers. But they told us if 36% of the students play Scrabble only, now this is very important, and this is a nice example of what I've been saying to you all along the way, right? Where the word only has commented. In the other ones, only didn't comment it. Here they told you those who play Scrabble only was 36%. That's why I could write the 36 here, even though I don't know what this is here, right? This is the unknown factor. This is the thing I don't know. So let me call that unknown X, right? And 48% of the students play checkers. Look again, very important word, only. So let's highlight that, only. See that word only? So that means I could take this 48 and put it in here. I don't have to take away the X from here like I did in the previous question. So this is a very nice addition to your knowledge base because it shows where in certain instances like this one, we had to take into account the X and do a subtraction because this was not only, right? Nor was this only, Q only. It would have, if it was Q only, it would have looked like this in set notation, right? Here they were very kind to you. They give you the words. They didn't write it in set notation. So once they tell you that, you know the figure goes there and this figure goes directly there. Okay. So the question was, what percentage of students play both? In other words, what percentage were lying in the intersection? So what is the value of X? Well, you guys know that 100% would be comprised of students who play in Scrabble, checkers, or both. Look at there, all students, which means 100% of the students. So let's put 100% above that so you'll know that is what it means, right? Play Scrabble only, chess only, or both. So it means that if 100, right, is made up of 1, 2, 3 added up together, then to get this one, we have to take away these 2 from 100 and it'll give us the remainder, which is those that play both or play both games, right? So 100% take away whatever this percentage is, which is 84%. The remainder will play both of them. And if you do that subtraction, you'll get 16, which is item B, right? So that was the answer for this one, B. The cost, let's go to 15. The cost of a calculator exclusive of sales tax is 120. Exclusive means they haven't added in the sales tax as yet, right? Susan bought a calculator and had to pay a sales tax of 10%. How much change would she receive from $140? Okay, but let's calculate the sales tax she had to pay. It was 10% of this. So 10% would be 10 over 100 times the cost, which when you work it out gives us 12, right? 10% means 10 over 100. So she had to pay $12 tax, right? You have to be able to do this without a calculator, remember that. So the total to be paid will be the cost of it, right? Exclusive of tax plus the tax. So when we add it, or we get the cost inclusive of tax, to get that inclusive cost, we have to add the original cost plus the tax, which gives us $132. Now, if we pay in 140, and this is the cost, then the change will be the difference, the subtraction of these two, which works out to be $8 as our change. That's option E. That's this one here. All right, so we go to this very easy one. Simple interest formula, you're supposed to memorize it. Principal by rate by time over 100. Remember, the main trick is that this time, sometimes they put it in months, but your formula requires it to be in years. Okay, so they didn't try to trick you here. It was actually in 4 years. This is what you invest in. That was your principal, and that was your rate per annum. So you just simply put your principal in, your rate in, your time inside the formula, and this is the formula you would come up with. They didn't ask you to work it out because they wanted to see which one of these was this, and it was actually the first one. Option A was the same. So your answer was E. Let's go down to number 17 now. A television costs $350. And when bought on hire purchase, so you go to courts, for example, and you want to purchase it, court say, make a deposit of $35, and you're going to pay for 12 months only $30, and that TV is yours. So you could get the TV immediately and get the benefit. Right? Now, to get that benefit of getting the TV right away, what you'd find is that the higher purchase price, when you add up everything that you pay, is going to be more than the cash price. So they're going to ask you now, how much is saved by paying cash? How much money you're going to save if you save up your money and you bought it one time? That's not a problem. Our higher purchase price is going to be the down payment of $35 plus 12 monthly payments of $30 each. That means over the 12-month period, we're going to pay 12 times 30, which is $360. So the total price going the higher purchase route will be the $360 that we paid over the 12 months plus the down payment of $35, which gave us a total higher purchase price of $395. Now the savings will be the difference between what we paid for higher purchase minus what we would have paid if we paid cash, $350. So the difference there is $45, and that would be our savings, which was actually item D, $45. In number 18, they say a plot of land is valued at $18,000. Land tax is charged at the rate of 70 cents per $100. What is the total amount of tax paid for the land? Okay, so for every $100 out of this 18,000, right, you have to pay 70 cents. So let's see how many hundreds we get in the 18,000, because for each 100 we have to pay 70 cents. Now 70 cents, I'll write it as 0.70 of a dollar, all right? But to calculate it, I am going to recognize that 0.70 is the same thing as 70 over 100. I mean, if I had a calculator, I could leave it like this, but remember, we have to do our own calculations without the calculator any multiple choice. I converted this from a decimal to a fraction, which means that this number, 70, goes on top. For the point, I put a 1, and for the decimal, the numbers after the decimal point, 1, 2, I put that number of zeros, 1, 2. So that's how I come up with this, right? And then I did my canceling down. So let's see what canceling down I could do. I could do this, divide 100, top and bottom. And then I could divide here by 10, here by 10. Then I'm going to divide the bottom by 10, and then the top by 10 as well. So I end up with 18 by 7, and then I work this out here manually, and I got $126, which was option B, right? You're supposed to be able to do calculations like this, okay? The next one, a loan of $8,000 was paid back in 2 years in monthly payments of $400. The interest on the loan as a percentage was, okay? Well, that's not a problem at all. Let's calculate how much we paid back, right? So the amount paid back will be 2 years, 12 months for each of those years, 12, $400 per month. The monthly payment was $400. So when I multiply 2 years, 12 months per year, $400 paid per month, I get the total amount paid back as $9,600. Now remember, I borrowed 8 and I paid back 96. So the difference between what I paid back and what I borrowed, that difference is really going to be the interest that I paid back. That will be $1,600. So that $1,600 is what we call the interest. Nice. Now, they wanted to know what is the interest on the loan. Now, the interest is always calculated using the amount that I borrowed, which is the 8,000. It is not calculated on what I paid back. So always remember it is a function, or it is based on this number, this 8,000, which is the loan amount. So how do I get the percentage interest? Well, first I find the fraction interest. What is the fraction of the total of the amount that I borrowed? Well, it'll be 1,600 over 8,000 will give me the fraction, and then to get the percentage, simply multiply that by 100. So if I work this out, I'll get 20%, right? You guys should be able to see that comfortably, right? I'm going to divide here by 100, divide there by 100. Divide here by 10, divide there by 10. So at the end of the day, I end up with 8 into 81, 8 into 6, 8 into 160 will be 20. So I end up with 20%. And that corresponded to item D, which is this one here. Okay, so let's go down to number 20. I'm going to open this up a little bit more. Right. So we get a little bigger, right? So let's look here. Let's see. A store offers a discount of 10% to customers who spend more than $20. If a customer's total bill was $80, what will he actually pay? So once you cross $20 in this person's store, it could be $21, you're going to get a 10% off of your purchases, all your purchases, right? So you reach a total of 80. So you're going to get a 10% off of that 80. So that's going to be a discount. So let's check your discount out. It's 10% of $80. 10% means 10 over 100. Of means to multiply $80. Do your calculation, right? You cross here, right? Divide top and bottom by 10. Then I'm going to divide bottom by 10, top by 10. So the answer is going to be 8 times 1 over 1, which is $8. So that's your discount. So what will he actually pay? Well, he's going to actually pay the original price of $80, take away the discount of $8, which is $72 being paid, actually. So that will be C. Let's see, item C, $72. All right. I hope you guys are okay so far. Don't forget, if you have any questions, you could raise it. Just unmute your mic and ask a question. And item 21, right? They're going to show you how do you pay for insurance. Now, how you pay house insurance is for every $100 that the house is worth, you pay 25 cents for every 100. Contents insurance, for every $100 that your contents is worth, you pay 50 cents. So we need to see how many sets of 100 we have in the value of the house. Right? Now, let's go down here. The house is valued at $50,000. So I'm going to see how many groups of 100 I could get in 50,000 by doing the division. And for that number of groups of 100, for every group, I have to pay 25 cents. Now, 25 cents is really 25 over 100 of a dollar, right? Because remember, you have 100 cents in a dollar. So that's the express in dollars because we want our answer in dollars, okay? So this calculation will give us the amount of money we have to pay in house insurance. Because remember, it's 25 cents, which is this here, for every 100 in 50,000. So let's see how many hundreds you're going to get, right? I'm dividing by 100 here, dividing here. So I'm going to get 500 groups of 100. And for every one of these 500 groups of 100, I'm going to pay 25 cents, which is this here. So, and that's dollars. So let's do a calculation. Divide here by 100 and therefore divide here by 100. So I cross 2 zeros, top and bottom. So now the calculation is going to be 5 times 25, which is 125. And that's going to be my house insurance. My contents insurance, they told me that the contents was worth 10,000. And I have to see how many groups of 100 in that 10,000. Let's see. Divide bottom by 100, top by 100. So I get 100 groups of 100, but for every one of these 100 groups of 100, I pay 50 cents, which is really 50 over 100 of $1. So 100 times this would give me how much money I have to pay for my contents insurance. So I'm going to divide the bottom by 100, the top by 100 by canceling 2 zeros, top and bottom. So to get my answer of how much I have to pay for contents insurance, it'll be 50 times 1 over 1 times 1, which is going to be $50. If I add up these two, I get 175, which actually is option E. So that is option E, which is $175. Okay. So the next one is number 22. The car presently valued at 12,000 depreciates at the rate of 10% per annum. What will be the value of the car 1 year later? Okay. Well, depreciation basically means that your asset or the item that you're looking at is going down in value because time is passing, right? And some items go down in value, some actually go up, they appreciate. For example, cars depreciate extensively, but artwork, jewelry, these things go up in value. Land usually go up in value over time. So this car is going to go down in value by 10% per annum or per year. 10% means 10 over 100 of whatever it started off at, which is $12,000. That will be the depreciation or the loss in value over the first year, right? If you do a calculation, divide the bottom by 100, this one top by 100, right? And then you're simply going to multiply 10 by 120, and that's going to give us 1,200. So this here is going to be the depreciation or the loss in value over the first year. So what will be the final value after taking away this depreciation or bringing down the value by this depreciation? Well, the value after 1 year will be what it started at minus what it falls by or what it depreciates by. I did the calculation here and I got 10,800, which you have to be able to do, of course. And so that would be the answer, which corresponded to answer A, 10,800. The product. What is product? Product means to multiply. So the product, so that's why I seen multiply, of a number P, the number P here, product of a number P, and it's reciprocal. Reciprocal means inverse or put 1 over whatever the number is, right? Or flip it. So in this case, put 1 over the number. So if it's P, the reciprocal will be 1 over P. So the product of a number P and its reciprocal, which is 1 over P, is what they are talking about. And if we look across here, the one that represents this is this guy here, which is C. So we had C as our answer. Next one, we have to work this out. Now, this requires us to use the distributive law of multiplication. So I rewrote this across here, and the red arrows show how we do or utilize the distributive law of multiplication. There's a multiplication. Yes?
This is Abraham, right?
Yes,
This
Abraham.
maths paper that we're doing here is year 21.
This 2014 paper 1.
Okay.
Yeah. And I had sent it to you guys on the WhatsApp chat.
Yeah.
Yeah. So that's what we're correcting, right? I sent it to you maybe 2 days ago. All right. So that's what we're correcting. Yes. So we're going to use the multiplication, distributive law of multiplication. So I'm going to put a multiply sign there just to remind you that even though it's not there, it's implied, right? And it means that this 5 has to be multiplied by the 2x, and it also has to be multiplied by the minus y, okay? And the minus 2 here has to be multiplied not only by the 3y, but also by the negative 5x, okay? Notice I am calling the signs in front of the terms. So 5 times 2x is 10x. 5 times minus y is minus 5y. Minus 2 times 3y is minus 6y. And then minus 2 times minus 5x is plus 10x. 2 by 5 is 10, right? So you guys are supposed to be familiar with the rules to get all the signs and so on. So this 10x and this 10x, when we add them together, we're going to get 20x. And this minus 5y and this minus 6y, when we combine them together, we're going to get minus 11y. And if you look, that corresponds to option E, 20x minus 11y. Next one, what is the value of these two things multiplied together? Well, the secret here is to multiply the numbers first. Minus 2 by minus 3 will give us plus 6. And then we multiply the letters thereafter. E times E is E squared. So you get 6E squared, and that is option D. We have this equation, and we want to find what X is. Right? Now, there are different words that we can use here. I will use both sets that you normally encounter. The one that you tend to hear first from your secondary school would have been take this minus 26, bring it over here and change the sign to plus 26. Take this minus 3x from here and bring it over and change the sign from minus 3x to plus 3x. 50 plus 26 gives us 76. And x plus 3x gives us 4x, right? I'll stop there and then come back. The other way that we could look at this is to add on the left-hand side plus 3x, which would take it out. And then we also add plus 3x on this side. And then on the right-hand side, we're going to add 26, which is going to take away this minus 26. But we must also add 26 on the left-hand side. That's the other way that is taught throughout the world. Right? But in both cases, you're going to end up with 76 here is equal to 4x. And if I divide this side by 4, and I divide this side by 4, I'm going to get that x is equal to 76 over 4, which is 19. Some people will say change the multiply sign that is understood here from multiply to divide when you bring the 4 over. So that's how you have division. And you get 19. In both cases, you're going to get 19, which is item D. In number 27, they say if 15 squared is 225, then the square root of 0.0225 is. Okay, so let's write down what they give us. 15 squared equal to 225. Now, what we understand is that if something squared is a number, if we find the square root of that number, we'll get back the original thing. So if 15 squared is 225, then the square root of 225 is 15. If 2 squared is 4, then the square root of 4 is 2, right? Now, you guys know that there's a major rule with square root is plus or minus, but in this case, the answers are not reflecting the minus option. So we're just going to deal with the plus, right? So we're going to deal with the fact that the square root of 225 is plus 15, and we're leaving it there for that, right? Now, we're going to have to use this to help us solve this part here. So what I want to find is the square root of 0.0225. So I wrote down what they want to find here. The square root of 0.0225. Fair enough. Now, I want to use this to help me here. So I'm going to try to bring this 225 into this number. And what I realize is that this number is the same thing as 225 divided by 10,000. Let's see. If I start at 225, let me just write it here for you. If I started at 225 and I divide by 10,000, that means I have to move the point 4 places to the left. That's 1, 2, 3, 4. Right? So what I'm saying is that if I start off with 225 and I move the point 4 places to the left, I will end up with this number, which is what they want me to find the square root of. So I recognize that this is the same thing as 225 over 10,000, or 1 with 4 zeros. And the square root of one number divided by another is the same thing as the square root of the top number divided by the square root of the bottom number, right? So this is something you're supposed to learn if you didn't know it before. Now, the nice thing about approaching it this way is that the square root of 225, we will already discover that up here to be 15. So I wrote the square root of 225 as 15. And I recognize that the square root of 10,000 will be 100. How come? The square root requires us to find a number which, when multiplied by itself, gives us the number that we want to find the square root of. So I asked myself, what number, when multiplied by itself, would give me 10,000? And the answer is 100. If I multiply 100 by 100, I'll have to have a 1 and 4 zeros, which is this. So the square root of 10,000 is indeed 100. So I end up with this as my answer. But do they have this over here? No. So I have to continue and divide. So if I have 15, that means that the point is going to be right here, right? And I have to move that point, if I'm dividing by 100, 2 places to the left. So moving this point 2 places to the left will bring me here, then here, which means I'm going to have 0.15, right? Or 0.15, which corresponds to answer B, right? 0.15. Now, the good thing about this, guys, is that even if you do ask the question here, you find it went a bit quickly for any reason. Remember, I'm putting this up on our YouTube channel, so you could go back and listen to the explanations over again if you didn't get it the first time, or if you need to review it, right? So that's why I'm taking my time, going through it slowly, showing you all the steps so you could go back and listen to it if you're getting any problems afterwards. In this one here, they say A is 5, B is 2, C is 4. Work out this first. Okay. Remember, an important thing is to use brackets. So I did that for all the terms. So A, B, and C. You notice I have A, B, and C in brackets. I wrote down 6. Then for A, I put in what they had there was 5. Then for B, this B here, for B, I put in what they had for B, which is 2. So I put that for B. Takeaway is this. Then this 2 here is this 2 here. And in the bracket will go what C's value is. And if you notice, C is 4. So I put 4 in there. Okay. So 6 by whatever this is. 5 by 2 here is 10. So 6 by 10 will give me 60. Negative 2 by 4 is negative 8. And 6 take away 8 is 52. So I get my answer to be 52, which was option B. Right? In number 29, they say if x is an integer. Now you guys have to know what integers are. And integers are the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 going up continuously to infinity on the right hand side. And then also the negative numbers, negative 1, negative 2, negative 3, negative 4, negative 5, going all the way down to negative infinity. So that is what integers are. It does not contain decimals or fractions. It's just those whole number values, both on the negative side and on the positive side, and it also includes 0. So we want to find numbers that fall into that category, but also satisfy this relationship. So let's look at this first part of the relationship where 4 is less than x minus 2, like this. So what I did was add 2 on the right and add 2 on the left. If I add 2 here, 4 plus 2 is 6. If I add 2 here, that 2 cancels with a minus 2 to give me x. So this condition says that 6 must be less than x, or you could read it as x must be greater than 6. So that's one condition. This part came from here. X minus 2 is less than 8. So I wrote it down. X minus 2 is less than 8. So on the left hand side, I added 2. That means that this minus 2 will cancel out. And I must also add 2 on the right hand side. So 8 and 2 will give me 10. Right? So what this is saying is that x must be less than 10. So we have 2 conditions to work with, but they want the smallest possible value of x. So this one will give us that because x must be less than 10, which means it could be 9. And it also must be an integer. So it could be 9, it could be 8, it could be 7. But then it has to be, x has to be greater than 6, or 6 has to be less than x. So we cannot go past 7. So the numbers here will be 7, right? 8 and 9 would satisfy both this and that. So out of those, the smallest possible value would of course have to be this guy here, 7. So we're going to use that as our smallest possible value, and that would correspond to answer A. In number 30, right, m star n is m squared minus n squared. So m star n is m squared minus n squared square root. Now, what is m and what is n? M in this case is 5 and n is 3. So we're going to link the 5 here to the m and the 3 here to the n. Good? So wherever m is, we're going to have to put the 5 there. That's why you see us putting 5. And wherever the n is, we're going to have to put it right there. That's why we're going to put 3 for n. And that's why you're seeing 3 come down instead of n. So m squared will be 5 squared, n squared will be 3 squared, then we have to subtract it, and then that answer we have to find the square root. So 5 squared will give us 25, 3 squared will give us 9. Square root has to be taken of that. 25 take away 9 is 16, and the square root of 16, we're using the positive value because that's all they have here is 4. The square root of 16 is 4 in this case, so that will be answer C, 4. Next one, 2 to the power of 6 divided by 2 to the power of 2, right? That's what I interpreted this as. So anytime you have the same base or the same numbers, 2 and 2, raised to different powers, this one is being raised to the power of 6, this one is being raised to the power of 2, there's a law. And the law says that the answer will be the same common base or number, which is 2, raised to the power of the difference of these two numbers. Difference means to subtract, right? If it was multiplication, we would have to add the two numbers. But because it's division, we have to subtract. 6 take away 2 is 4. So the answer is 2 to the power of 4, which is B. B. How many kilograms are there in 1 ton? Well, you guys are supposed to know that that is 1,000 kilograms in 1 ton, which is item C. So that's a knowledge-based question, right? Know those conversions. Something I just remembered, just as a point of note, an odd one that I saw in something long ago, but it's useful. I'll just put it in here as an addition, kind of in line with this, where they ask how many meters squared are there in 1 hectare, right? And the answer was 10,000 meters squared in 1 hectare. It was a very odd question. So I just raised it here to give you some more value in this multiple choice session, right? So you could take a note of that, put it in your book. That will help you to recall things important, you know, shortly before the exam. And then you could just revise that in case it comes in the multiple choice. You'll probably be one of the few people who would know the answer to it, right? That hardly ever comes, but I saw it come in an exam already. Now, if it took a speedboat 9 hours to travel a distance of 1080 kilometers, what was its average speed in kilometers per hour? If it took a speedboat 9 hours to travel a distance of this, what was its average speed? Well, average speed, which I represented as S, is the total distance D divided by the total time T. Right? The total distance traveled was this. The total time taken was this. Notice I'm putting the units to keep it close to my mind in case they change the time and they put minutes, I'd have to convert it to hours, right? And if they had this in meters, I'd have to convert it to kilometers because they wanted the answers in kilometers per hour. Notice how they wrote kilometers per hour here. Let me show it a little bigger so you'll be able to know. Kilometers h to the minus 1 is the same thing as kilometers per hour if we use h to represent hour, right? Hour could be h or hr, right? Or sometimes they write it as kilometers, and instead of putting the over like that, they put slash hours, right? All of these mean the same thing. And then it's just a simple division. 9 could go into 108 2 times, and then you have your 0 here. So the answer here will be not 2 times, but 12 times, sorry. 9 could go into 108 12 times. And then, of course, you have the 0. So the division here will give you 120 kilometers over hours, which will be kilometers per hour. And that was item C, 120 kilometers per hour. In number 34, the distance around a lake is 8 kilometers on a map. Now, there's an important one, so I want you to pay attention to this, right? This is a tricky one. So let's look at the steps to do it, right? On a map. This distance around the lake is represented by a length of 2 centimeters. So there you see the 2 centimeters, right? The scale on a map is, right? So you have all these choices. Now, let me show you how to do this. 8 kilometers in real is represented by 2 centimeters on the map, right? So 2 is representing 8, but 2 what? 2 centimeters is representing 8 kilometers. When you do a scale here, these have to be the same units, all right? This is centimeters and this is kilometers, so it cannot stand as it is. I have to convert one or the other. I have to convert it so that both sides are either centimeters or both sides are kilometers. I am going to convert it so that both sides are centimeters. That's a lot easier to do. So this side is 2 centimeters, 8 kilometers. Now, in every kilometer, there are 1,000 meters. So I'm going to convert 8 kilometers to 8 times 1,000 meters or 8,000 meters. But we need to go down to centimeters. And every one of these 8,000 meters, right, each of those meters is 100 centimeters. So to convert this 8,000 meters to centimeters, I have to multiply it by 100. So this number here would be the distance in centimeters. So that'll be 8 and 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. So what we are saying is that 2 centimeters on the map represents 800,000 centimeters. Now, I'm going to divide the left-hand side by 2. 2 into 2 is 1. I therefore have to divide the right-hand side by 2. 2 into 8 is 4 with these 5 zeros, right? So that is saying that 1 centimeter on the map represents 400,000 centimeters in real on the ground. So the scale, therefore, let's put in centimeters. So the scale, therefore, would be 1 to 400,000, which is actually item D. All right, that's item D, right? So I went through it very slowly. Again, you could always go back through if you're not so clear on it right away. In this one, we did this one already. This was also in the last paper, 2012, right? But I go through it again quickly. For any sector, to get the arc length, P to Q, which we call L, when we did it in our studies, that arc length there is equal to 2 pi r times theta over 360, but 2 pi r is the same thing as the circumference. So I use this as the circumference here, C. So the original equation that you would learn is 2 pi r times theta over 360. But this 2 pi r is the same thing as the circumference C. So the arc length L, they told us, was 8 between P and Q. So that's 8 is equal to the circumference times the angle theta, which is this angle here. Right, this angle here is theta over 360. So I put 60 over 360. Now if I divide here, top and bottom, I'll get 1 over 6. Dividing the top by 60 and the bottom by 60, I'm going to get this. So 8 is going to be C times 1/6. So, or 8 is equal to a sixth of C. So therefore, C has to be 6 times 8. Or if you multiply the left-hand side by 6 and the right-hand side also by 6, 6 8s are 48. 6 times a 6 will give me 1. 1 times C is C. So therefore, 48 centimeters has to be the circumference, which coincidentally is option C as well. 50 guests each had 2 glasses of champagne. So how many glasses of champagne was sold? 50 guests by 2 glasses each. That's 100 glasses of champagne, right? 50 by 2. And each glass held 150 milliliters. So the total number of milliliters would be these 100 glasses, right? Each holding 150 milliliters. So this calculation here would give me the total amount of, total volume of champagne that was served, right? Or used. Now, every time we gather 1,000 milliliters, that'll be 1 liter. So to convert all these milliliters to liters, I have to divide by 1,000 to see how many groups of 1,000, because every group of 1,000 milliliters is a liter. So we simply work this out. Now, 50 times 2 is 100. So if I cancel this and I cancel 2 zeros here, meaning divide by 100 top and bottom, I'll end up with 1 here and 10. If I divide this final 10 here, that 0 comes out, and divide this by 10 as well. So I end up with 15. So the answer is 15 liters, or item C. That's number 36. We have to find the area of this trapezium, and there's a formula. It says that the area of a trapezium is a half times the sum, that's why we're going to add, the length of the parallel sides. So this side here, SR, is parallel to the side PQ. So the sum of those lengths will be the sum of 8 and 12, that goes here, times the perpendicular distance between these two sides. The perpendicular distance between the 8 and the 12 will be this distance here. Perpendicular meaning there's a 90 degree, which is shown right here. That's a 90 degree. Hence, the perpendicular distance is 5. So that's what goes here in this calculation. So then all we have to do is work it out. 8 and 18 is 26. A half of 26 is 13. 13 by 5 works out to be 65. And the unit of area, if the length unit is centimeters, would be centimeters squared. That's option B. So the answer was option B. Right? A boy leaves home at 9:15 and arrives at school at 10:05. So therefore, how much time did he take to go from here to here? Now you could check it in any way, but there's a nice way that we use here where we write down the finish time, the start time, and we do a special subtraction. And here how the subtraction goes. 15 minutes, because this is the minute side, take away from 5 minutes is not possible. You have to do a subtraction to see how much time was taken. So we borrow from the hours side. So let me write something here for you so you'll remember. This is the hours side and this is the minute side. Okay. So we're going to borrow from the hour side, borrow 1 hour. So this comes down to 9. And I'm carrying an hour over onto the minute side. But an hour is 60 minutes. So 60 plus the 5 that was there originally will give me 65 minutes. So now I can take away 15 minutes from 65 minutes and that'll give me 50 minutes here. And 9 hours from 9 hours is 0. So the time taken between 9:15 and 10:05 would be 50 minutes. There are multiple ways you could check it, but I've found that this way is very effective. So 50 minutes is what was taken. Now, there's a formula. The average speed S is equal to the total distance traveled divided by the total time taken. From this equation, if we cross multiply, S times T will be equal to D times the 1 underneath here. So let me put the 1 so you'll see it. 1. So S times T is D times 1. S times T is equal to D times 1, which is D. So we are interested in the D because how many kilometers? Kilometers mean the distance. So to get the distance traveled, I have to multiply the speed that he was traveling at, which was 6 kilometers per hour. That's this S here, 6, times the time that he took. Now the time he took was 50. So if I wrote down 50 here, right, I would not have gotten the correct answer. I had to actually convert it to hours because remember this is kilometers per hour. So 50 minutes as hours, right, converted to hours, will be 50 over 60, right? Because remember every 60 minutes is an hour. So it's 50 60ths of an hour, right? So the speed will be 6. The time will be 50 60ths of an hour, which is 50 minutes. And therefore, this is a calculation to get the distance traveled. 6 will cancel into 60 10 times. 10 into 50 will be 5 times. So the answer would be 5 kilometers would have been traveled. 5, and that's option B. The volume of the cuboid is 320 cm cube. And the height is 5. So this is 5, right? And the volume is length by breadth by height, right? The height is 5. So this height is 5. But they told us something special. They say, if the cuboid has a square base, it means that the length and the breadth are the same value. So I'm going to use the length here and the breadth to be the same value L, because that's what a square base would mean, okay? The length and the breadth would be the same. So the height would be the 5, and the length and the breadth would have the same value L. Let's use L to represent both of them having the same value. So L by L, this would be L squared. So I'm going to write down L squared here now because remember the breadth and the length is the same distance because it's a square. So L by B is the same thing as L by L, which is L squared. The height is 5. So the volume, which is 320, is L squared by 5. So if I divide by 5 on both sides, or some people say bring this multiply by 5 over and change it to divide, that'll be equal to L squared. Now 320 divided by 5, you could work that out, and you would get 64. And then L will be the square root of 64, which would be 8 centimeters. So the length of one of these sides of the square base of this cuboid is going to be answer E. 8 centimeters was answer E. Right? In this scores, they wanted to know what is the modal score. What does modal mean? Modal means that value that appears most often. So the modal score would be 3 because it appears most often. It appears 1, 2, 3, 4 times. There's no other number that appears more often, and therefore 3 would be the modal score, which is option E. Right? What is range? Range tells us the difference between the largest and the smallest value in the scores. So the range of scores would be the difference between the largest score, which is 10, and the smallest score, which is 2. So that works out to be 8. That was option C. So that's what range means, the difference between the largest and the smallest score, because they wanted the range of the scores. Next one, 600 students write an exam. The probability of a randomly selected student failing the exam is 1/5. Okay, how many students are expected to pass? Okay, well, if 1/5 are expected to fail, then 4/5 would be expected to pass, right? This here is those expected to pass. Good. So once we know 4/5 are expected to pass, then that 4/5 must be equal to the number that we expect to pass over 600. Because remember, probability is the frequency of the event over the total frequency, the desired outcome over the total number of outcomes. So there are 600 students, and we want to know how many will pass. We know that probability is 4/5. So we could cross multiply. 4 times 600 is equal to x times 5. Therefore, x is 4 times 600 over 5. Or 4/5 of 600 will give us the value of x. And that would tell us how many people would be expected to pass. All right. And let's calculate 4/5 of 600. 5 into 600 will be 120. 120 by 4 is 480. So that'll be option B. The answer is that 480 students are expected to pass. In a class of 20 students, 12 are girls. What is the probability, right, that a student chosen at random is a boy? Okay, well, let's see how many. If there are 12 girls, let's see how many boys there are. 20 in all, take away 12 girls gives us 8 boys. So the probability of a boy being chosen will be 8 boys, 8 out of 20 students. That's how you get probability, what you want over the total. So it'll be 8 over 20. Let's divide the top by 4 and the bottom by 4. 4 into 8, 2, 4 into 25. So the probability will be 2/5, which is B. If the mean of the 4 numbers, 4, 8, x, and 12 is 10, then x is. We did this in the last one, but I did it again. Mean means to add up all the numbers and divide by the number of numbers. So there are 4 of them, so you divide by 4, and that is equal to 10. They told us the mean is 10. So I put the 10 over 1 and I cross multiply. 10 by 4 will give me 40. And this here by 1 would give me this. But let's see why. Because 4 and 8 is 12. 12 and this 12 is 24. Right? So 24 plus x will be on top. And when I multiply 24 plus x by 1, I'll get back the same 24 plus x. So 40 is equal to 24 plus x. So to get x, I will minus the 24 from the 40, and that gives me 16. So x, which is the number missing here, will be 16, and that is item D. In this case, it told me that 120 degrees from the diagram was milk, and this portion here was lemonade. Now, if you notice, AC is a straight line. Straight line. So it means that x and 120 must be equal to 180 because it's a straight line, x being the angle here. So that means that x must be 180. Take away 120. Angles on a straight line must add up to 180. That means that x must be 60. Of course, 60 plus 20 will give me 180. Now, 60 degrees represents those people who like lemonade, And right here, they say 12 students prefer lemonade. So we're going to use that to our advantage. 60 degrees, which is this value here, is 12 students, representing 12 students. So 1 degree would represent 12 over 60. That means I divide here by 60 and there by 60. 1 degree represents 12 over 60. They want to know what is the total number of students. Well, the total number of students will be the entire circle, which will be 360 degrees. So if 1 degree is 12 over 60, then 360 degrees, which will be the total number of students, will be 360 times this. And of course, if you work this out, 60 will go into itself once and into 360 6 times. And then 6 times 12 is 72. So 72 students would be all of the circle, represent all of the students in that circle. So that would be option B. All right, so that's how we did that one. 46, all right. This is a nice question. I haven't seen it often, but you're supposed to know this, right? And what it is which of the following diagrams best illustrates a function, right? You have to know what a function is, and a function is a relation where the x value must map onto one and only one y value. That's how you distinguish a function from just a plain old mapping or relation. So if you notice this x value here, which is where we start is also always called the x, and where we end up is always called the y, right, in our mathematics at this level. So this x value is mapping onto one value of y, but this one isn't. It's going to two values of y, two different values of y. So it cannot be this. That'll be wrong. So let's x that off. Let's go to the next one. This is going good. This one is good. But this one is going to two different values of y, one here and one here. So that cannot be a function. Let's go to the next one. This guy is going to 2, 1, 2. So it cannot be a function. This is going to 1, right? This is going to a different one, good. This is going to another one. So all of these are going to 1 and only 1. You're not going to 2, not mapping onto 2. Every x value is mapping onto only one value of y. So that is quite good, no problem. So that would be option D, right? What is noteworthy is that if we had 1, 2, I'm showing you another possibility here, right? He went to 1, right? He went to the same one. He went to this one, right? This would also be a function because these three are going to 1 and only 1. Even though these two here and here are going to the same one, it doesn't matter. They are going into one value. So that would still make it a function. Once you go to one value, no problem. Each x going to one value, no problem. It could be the same value as another one, but it still would be a function. All right. So let's continue to 47. So the answer, of course, was D for this one. In 47, they say the equation of the line which passes through the point 0,2 and has a gradient of a third is, right, this is a very nice one because it is a little different from what we had done in our tutorial when we looked at equation of a straight line. Now, I did mention to you that there are some of them whereby they give you enough information that you could just go and write down the equation of the line just with the information without doing any calculations, right? And this is an example of what I mentioned to you right at the end of that topic, right? Whereby, very importantly, let's look at the things they gave us. They say this line is passing through the point 0,2. So it's passing through 0,2. So one of the x values will be 0 and a y corresponding y value to this x value will be 2 on that line. So 0,2 is passing through there. Let's identify that on this little graph here. 0,2 would be this point right here. Why is that 0,2? Because to get there, if I start at the origin where I must always start, I do not need to go to the left nor to the right to get here. That means my x movement is 0. That means my x coordinate is going to be 0. Good? But I have to go up two spaces, 1, 2, to get to the y value, to get to the point. So I have to move y two movements or 2 units. So my y coordinate is going to be 2. So that's this point here. And that's a very, very important point. You see this point 0, 2? It is actually the y-intercept. Now the y-intercept is also written down as 0c. And this c here is this c here. See this c is this c. So this here, because the x-intercept is 0, that's how you recognize, sorry, because the x-coordinate is 0, that is our clue for the y-intercept. This number here is going to be our y-intercept, which is c in the equation y equal to mx plus c, which is the equation of a straight line. So in a very sneaky way, they give us this value of c here. Because once the x-coordinate is 0, the y-coordinate tells us what the y-intercept is. So this here is really the y-intercept. So it's a very sneaky way of telling us what the y-intercept is. And once we know the y-intercept, and we know the gradient, because it tells us it has a gradient of a third, that means m value is a third. Right away, without doing any calculations, we could write the equation of the straight line. How come? Because the equation of the straight line is y equal to mx plus c, where m is the gradient, which they told us was a third. So we could write the third right there. And c is the y-intercept. And they already told us what the y-intercept was. It was 2. There it is, 0, 2. That's the y-intercept there. So this 2 represents c in the equation, so we can just write it there as well. If it was 0 minus 2, we would write minus 2 here. So the equation of the straight line is y is equal to a third x, this being the gradient, plus c being the value 2 here, which is the y-intercept value. So that is B. Very, very important example. Take note of it. It utilizes what I call peripheral knowledge, something that the teacher doesn't focus on a lot, except in a case like this. Yes, go ahead.
Well, in the equation here, you're saying y is equal to a third x plus 2.
Yeah.
But I see the same thing for d. D is also wrong.
D. A third x. A third x. I said B.
Yeah.
Yeah. Thanks very much. It should be D and not B, because B is 3x. And this is that third x. You're quite correct. So let's fix that. This is D. Yeah? I was looking at a third and I was looking at 3 and seeing a third. But you're right. This has a gradient of a third. So look, I wrote the third here, right? But I'm looking at B, and for some reason my mind and my eye was seeing a third here. But if you look at it, third here is really this one, right? So you're correct. It's actually D is the answer and not B. Thanks for that, Abraham. Right? If
Yes,
you
sir.
see anything else like that, point it out. You're quite correct. D is this here, which is what I wrote correctly, is actually this one and not this one. Okay? So the answer is D. So let me shift that dot here to D. Nice. Okay, so let's go to the next one. The diagram represents the mapping. Okay, so if this is X, then this will be Y. This is what X is mapping onto right here. So what do I do consistently to all of these X values to get all of these Y values? Yeah, and the answer is, well, we could check it out. Let's try 0. If I take 0 for X and I add 2, I'm going to get 2, and that's not what happened here. So that's right away, that's wrong. Let's try this one. 0 plus 1 is 1, so that works out nicely here. Let's go down to this one now. Let's take 1 and put it here. 1 plus 1 is 2, so that's working out good here. Let's try this one. 2 here. 2 plus 1 is 3, but I'm not getting 3 here. I'm getting 4. So this is not right. Let's skip this one and come to this one. X mapping onto 2x. Well, if x is 0, put 0 here. 2 by 0 is 0. And that's not correct because it's mapping onto 1. So that's not correct. So right away, we eliminated these 3 here. And therefore, we could say that the answer is C. Yeah, but we could also try it out if you want to try it out and see if it actually is C, because this is really supposed to be 2 to the power of x. It's very small, but it's really 2 to the power of x. And we could try it out and see, even though we know by elimination that that is the answer. Let's try it out though. If I take 0 and put it here, it'll be 2 to the power 0, and any number raised to the power 0 is 1, which is what they had here. So that worked out. Let's try 1 for x now here. 2 to the power of 1. Anything to the power of 1 as itself. 2 to the power of 1 is 2. Let's see if that is this number here. Yes, it is. So that worked out. Let's put 2 here. So that'll be 2 to the power of 2, or 2 squared, which is 4. Let's see if that 4 is here. Yes. And the last one is 3. So 2 to the power of 3, which is this one, which is 2 by 2 by 2. 2 by 2 is 4. 4 by 2 is 8. So this 8 should be here. Yes, it is. So again, we just confirmed that this was indeed the answer, C. All right, the next one. Right, is this one. So if f of x is this, then f of minus 3. It simply means take the minus 3, and wherever you see x, put a bracket and then put the minus 3 inside of there. So if you notice, x was supposed to be here, 2x squared. I put a bracket and put the minus 3 in there, and I followed through with what they wanted me to do. They wanted me to square it, multiply it by 2, and then minus 1. Square the x, multiply by 2, minus 1. So squaring minus 3, I'd get 3. Multiplying by 2, I'd get 18. And then when I take away this one, I'd get 17. So that'd be option C, which is this one here. Option C for that one. Number 50. Which of the following represents, which of the following sets is represented by the function f such that x maps onto x squared plus 3? X is mapping onto x squared plus 3. Well, they're giving us x as a member, or all the values of x are members of this set. So it means that we must take x to be 0, 1, 2, and 3. That's what they did here. If you notice, x is 0, 1, 2, and 3. All those are the x values. 0, 1, 2, 3. 0, 1, 2, 3, right? And then these are the corresponding y values, right? Here is the corresponding y values. And we need to see which of these here would give us all the correct corresponding values in these locations. Here, 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 and here. Or here, 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 and here, right? So all of them give us 0, 3, 0, 3, 0, 3. So all of them give us 3 here. So we cannot decide what the answer is by looking at this one. Let's look at this guy here, right? Now, if we take x to be 1, which is these ones here, this is the x value, this is this, and we put it into the function here, 1 squared plus 3. 1 squared plus 3 is 1 squared is 1, 1 plus 3 is 4. So we're looking for in this column where we see 4 as the y value. So we saw 4 here, so I could tick that. It's not here, so this is wrong. It's here, so I can tick that. It's not here, so this is wrong. So right away, we eliminated the B and the D because they had 2 answers that were wrong. So we down to A and C, right? So let's continue with 2. So if I take 2 and I put it for x here, it'll be 2 squared plus 3. 2 squared plus 3. 2 squared is 4. 4 plus 3 is 7. So I'm expecting to get 7 next to the 2. So I got the 7 here. That's correct. This is already eliminated. So let's see if I got 7 next to the 2 here. No, I didn't. I got 5. So that eliminates C as well. So right away, I know that the answer is E. But if I wanted to check 3 in the function, I could, which I did. So let's check it. 3 for x here. So that'll be 3 squared plus 3. 3 squared plus 3. 3 squared is 9. 9 and 3 is 12. So this 12 is this 12 here. And therefore, A is indeed the correct answer. All right. So that's how we did it by a process of elimination for number 50. Number 51. The range of f such that x maps onto x squared for the domain, and this is the domain -2, -1, 0, 1, and 2. So let me put in the squared here, right? And we have to figure out what are the values, right, that we will get when we use these values for x in this function. Let me say that again. What are the different, we have to figure out what are the different values we're going to calculate when we take these numbers here and use them for x in this relationship here. So x is mapping onto x squared. So the first value I'm going to use here is minus 2 inside of here. So minus 2 for x, this here would be the values of x, right? So these are values of x values, right? And I'm going to take minus 2 and put it for x here. So that'd be minus 2 squared. Minus 2 squared is 4, right? Are we seeing 4 in here? Yes, all of them have 4. Okay, no problem. Let's do the minus 1 now. Minus 1 squared is 1. Are we seeing 1? Right, so this one is out here because there's no 1 in it, so we could take that out. Let's deal with 0 now. 0 squared is 0. Yes, 0. Are we seeing 0 in all of them? Yes, 0 in all of them. Let's go to 1 now. 1 squared, right? 1 squared is 1. Yes, we've seen 1 in all of them still, right? We've seen 1 here and we've seen 1 here. And the last one is this 2 here. Let's put 2 squared. 2 here squared. 2 squared is 4. Are we seeing 4 in all of them? Yes. So we've seen 4 in all of them. Good. But the question is the range. In other words, what's the smallest value and what's the largest value that this goes through, right? The smallest value is a 0. Look at here. And the largest value is 4. Look at here. So the range of values would be 0, 1, and 4. Even though it's repeated, that's still the range of values. It's not, it doesn't go lower than 0 and it doesn't go higher than 4. So you put in those values, 0, 1, and 4, right? In no case did you get a negative answer. So these would be out because they're not there's no negative value when we calculate it, because anything squared will always be positive. So these here could be taken out because of the or by virtue of the fact that they're including negative answers inside of there. So they are totally out. But this one is the correct one because it shows to the smallest value, the next value, and then the highest value. All the possible values will be the range. So 52 and 53 refer to this, right? And let's see what this is about, right? Anytime I see a X, right, I think of something called vertically opposite angles, because vertically opposite angles deal with X's. And what it basically says is that angles on either side of an X, right, opposite sides of the X, are equal in value. So this angle theta and this one here would be the same. And the one on this side here, 58, on this side, we will also get 58 degrees, all right? So any relationship where we could use that is what we're going to be using here. They say, which of the following angles are equal? And if you check through all of them, the only one that shows what I just showed you here using vertically opposite angles principle would be item D. Let's look at D. Item D says that the angle ABD, where's the angle ABD? Well, you start at A, right, which is here. You go to B, right? And when you reach B now, you swing back and you go to D. So the angle captured in there would be 58 degrees, right? So that's the angle ABD and the angle CBE. So let's look at CBE. CBE means you start at C, you go down to B, and then you move to E. The angle captured in that movement would be this angle here. So therefore, that's agreeing with our vertically opposite angles, 58 and 58, they would be equal. So that's item D. Let's look at 53. The measure of angle ABE. Okay, well, where's ABE? Let's check it out. A, B, and then we come down to E. So ABE is this angle here. How can we find out what that angle is? Well, let's say that this angle is theta, then this one is theta. If we add them together, that'll be 2 thetas. If we add these together, that'll be 2 58s, or 2 times 58. And adding these 2 thetas and these 2 58s will give us the total angles in a circle, which is 360 degrees. So 2 thetas plus 2 times 58 angles, 58 degree angles, will give us 360. Okay, so let's use that to our benefit. So using that here. 2 theta plus 2 times 58 is 116 degrees, right? Let's put these there, right? Is going to be 360. So now if I want to get what 2 theta is, I'll take this 360 and minus 116 from it, right? And what you'll realize is that 360 minus 116 give me 244. And then to get theta, I have to divide by 2 here and divide this answer by 2. When I divide 244 by 2, I get 122 degrees, which is actually option B, right? So we got option B, which is 122 degrees. In this case here, if O is the center of a circle, then what is y degrees? What is this? Well, we use here a theorem called angle at the center is equal to 2 times the angle at the circumference. So the angle here is always going to be twice the angle here. Okay? So whatever this is, we have to multiply it by 2 to get this angle here. So the angle at the center, which is this y, is going to be 2 times the angle at the circumference. So y, therefore, is going to be 2 times 50 or 100 degrees is going to be the angle at the circumference, which is angle D, 100 degrees. Okay, the next one, right? They're saying in this one that item 55 refers to the triangle PQR below. So we're looking at this triangle, and they're saying in the triangle, cosine P may be expressed as, well, cosine P means cosine of this angle here. Now, cosine of any angle, let's call it theta, is equal to the adjacent side over the hypotenuse. Now, the adjacent will be the side that is closest to this angle here. And that side is going to be here. This is going to be the adjacent, PQ. The hypotenuse is always the side that is opposite to the right angle or the side that is longest, which is going to be opposite to that right angle here, and that is going to be the hypotenuse. So cosine theta, which is given by adjacent over hypotenuse, if you need to recall it using SOHCAHTOA, that will help you to remember this, the acronym SOHCAHTOA. All right, you can use the adjacent side as PQ on top and the hypotenuse as PR below. And this here will be the cosine theta or cosine of P, which is what we are interested in, cosine of angle P. And that corresponded to C, which is PQ over PR. In number 56, they said the image of a point P minus 2, 3 under a translation 3, 4 is. Now there's an equation that we need to learn for translations. And the equation basically is the start point, which is also known as the image point or image, plus the translation vector will always give us our end point or object point. And this is a vector relationship. So we put everything as vector, which is vertically as components. So our start point, which is P, right? Because they want to get the image of P. That means P had to be the object or the start point, minus 2, 3. In this equation, we write it vertically. That would give us the position vector of our start point as minus 2, 3. We add to that the translation vector that we are using, which is 3, 4, because it's going under this translation here, 3, 4. And we're going to end up with our endpoint. Now, let's add minus 2 and 3 together, which is here. 3 and 4 together, which is here. Minus 2 and 3 would give us 1. 3 and 4 would give us 7. So this really gives us the position vector of the image point, right? That's the image point or the end point. But they don't want the position vector, which is like this, of the image point. They want to get the coordinates, because you notice these things are written horizontally. But what we learned in vectors is that once we have the position vector here of the point, we automatically have the coordinates of that point as well. All we have to do is take these components, which are written vertically, and write them horizontally like this. So the image point of P under this translation vector is 1, 7, which corresponds to option C. Right. In number 57, the transformation which will map triangle, right, which will map triangle PQR onto P prime, Q prime, R prime. In other words, take it from here and map it onto this one is. And fortunately, they give us the right answer up front. It's a rotation of 180 degrees about the origin. In other words, the origin is right here. And if we were to connect the origin to each one of these vertices and move it through 180, look at R, for example. If we move that through 180, we're going to end up at R prime, right? If we move P through 180, we're going to end up at P prime. If we move Q through 180, we're going to end up at Q prime, using here as the origin, right? So right away, we can see that this option of a rotation of 180 about the origin is correct. Another way, if it wasn't so clear, is by using a method whereby we connect all corresponding image and object points, and the lines that connect all corresponding object and image points, they will intersect at the origin, which is always, which in this case is the center of rotation, right? Whenever you connect the corresponding object and image points of object and image that you think are coming about because of a rotation, then where those connecting lines that connect the object points and the image points intersect, that would be representing the center of rotation. Now, in these situations, what I recognize is that 99.9% of the times, the center of enlargement or rotation is the origin. So you could always try from there first. But if you use this method, we could have quickly connected R and R prime, which is this line here, right? Q and Q prime, which would be a longer line going from here to here, and P and P prime, which is a line going from here to here. And what you would notice if you did that is that all of them are going to go through right here, which means that you already know the center of rotation, or it could have been the center of enlargement. So then you would have said, okay, center of rotation would mean that if I rotate R about this point, I should get it to R prime if I go through, well, in this case, 180 degrees. And therefore, you could apply it to the other points and you would see that it actually is working out. Okay, so the answer for this one was actually A, right? A rotation of 180 about the origin. The next one, which is number 58, they give you two similar triangles and they want you to find the length of MO. Now, what similar triangles tell us is that corresponding angles are equal and ratios of corresponding lengths are equal. Okay, so what does that mean? It means that this bottom angle here will be the same, this top angle here will be the same, and the angle on the right hand side here will be the same, which is C, if they are similar triangles. What it also says is that corresponding lengths ratios will be the same. So if I take, for example, AB, which is this length, and divided by the corresponding length on the other side, which is MN, AB over MN, the answer that I get from taking that ratio will be the same as the answer that I would get if I take the corresponding ratio of other corresponding lengths. So for example, if I take the ratio of AC, which is the hypotenuse on the bigger triangle, and divided by the corresponding hypotenuse on the smaller triangle, which is MO, then the answer should be the same. So AB over MN should work out to be AC over MO, which should work out to be CB over ON, right? So you're looking at image over object at all times. You could also do object over image, right? But you must have the same order. So if I'm going hypotenuse over hypotenuse, image to object, then I must go base on image over base on object. Oh, sorry. Let's say this here is the object and this is the image. Let me start over. Hypotenuse. Let me put it so we'll have something to work with. Let's say object image. Or this is not a transformation. So let's use something different. Let's use 1 and 2. So if I take the hypotenuse on triangle 1 and divided by the hypotenuse on triangle 2, like I did here, then all other ratios has to be 1 over 2. So I'd have to look at the base on triangle 1 over the base on triangle 2, and that ratio would be the same as the first ratio. And then I'd have to look at the vertical, which would be CB on triangle 1 over the vertical on triangle 2, which would be ON. All of these will be equal, right? That's a property of similar shapes, whether it be triangles or rectangles or whatnot. The ratios, once taken in a particular order, will always be the same. So I'm going to use that at my benefit here to help me solve this question. So I'm going to say that AB, which is 6 over MN, which is 3, MN, AB, which is 6 over MN, which is 3, that's this, must be equal to AC, which we know, 7 over MO, which we don't know. And once I could get that, I could cross multiply and get my answer, because 6 times MO must be equal to 7 times 3. That's cross multiplication, right? And then MO would just be 7 times 3, which is 21, divided by 6, right? Divide by 6 on both sides. 21 divided by 6 works out to be 3.5 centimeters, which is option C. So that's how we did that one. That is called similar triangles. Now, in this diagram, triangle ABC is mapped onto triangle A prime, B prime, C prime. So we started here and we ended here, right? Where G is the center of enlargement. Not G, but O, this is center. What is the scale factor of the enlargement? So we're starting at a smaller triangle and ending up at a bigger triangle. So it means that it has to be something greater than 1, the scale factor, right? That's something you got to take note of. Now, to get the scale factor, K, it's always the image over the object. It could be the image length over the object length, or it could be the image distance over the object distance from the center of enlargement. So let's look at image distance. Remember, this is the image here, and this is the object. So the image distance, let's say, of C prime from O will be OC prime. So I put that on top, that's the image distance. Over the object distance, corresponding object distance will be OC. So that's how you get your scale factor, right? If we had lengths of these sides, we could have used that as well, but we didn't know any lengths. It wasn't easy to find that. So what we did, oh, you could, because look, a length here, that's 2, and that's 4, using this scale. So you could use that too. But I decided to use the distance from the origin. So I used the image distance from the origin, which is O to C prime, and that was 4 units, divided by the object distance from O of C. So that's OC. That's 2. So I got 4 over 2, which is 2, and that gives me option D, which is this one. If you wanted to use image length over object length, you could do that as well, right? How could we have done that? Well, image length over object length. Let's check this image length here. That'd be A prime, C prime. That's our image length. Over the corresponding object length would be AC. Good? Let's see what we get. A prime, C prime. If we come across here, that will be 4. So A prime to C prime will be from 0 to 4, which is 4 units. So I'm going to put that 4 in, right? And that will be over AC. AC is from here to here. A is in line with the 2. C is in line with the 0. So AC will be 2 units. So we're going to put 2. So that will also work out to be 4 over 2, which is 2. So our K value in both, using both calculations, would be 2, which is option D. In this last item, which is item 60, I believe we did it as well in 2012 paper. They say, right, item 60 refers to this diagram here. It shows a ladder 5 meters long. So I put in the length of the ladder from here to here is 5 meters, right? leaning against a wall. The foot of the ladder is 3 meters away from the wall. From here to here is 3 meters. Good. So now they want us to find out how far up the wall does the ladder reach. So that means how far up this wall, which is the distance x. I put in that. Does the ladder reach? So I'm observing a right angle here, which means that I have a right angle triangle. And that means I could use Pythagoras' theorem if I have two sides and I'm trying to find the missing side. Now I know the answer right away here is 4 because I learned the Pythagorean triangles that I had given to you. And that's the most basic of the 4 or 5 Pythagorean triangles that I had made you learn. So go back in your notes and you should see those Pythagorean triangles. This is the most basic one, which was made up of 3, 4, and 5. But if we didn't know it, we could work it out. In a multiple choice, you don't need to show working. So you would have had a distinct advantage over anybody who didn't know it. You could have immediately gotten X there to be 4, answer A. If you did not learn it and you had to apply the Pythagoras theorem, it's very easy. Which says, so Pythagoras says that in a right angle triangle, the hypotenuse squared is equal to any one side, let's call it side 1 squared, plus the other side, let's call it side 2 squared. That's the Pythagorean triangle. Another way of stating it is that in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. So those are two ways of stating Pythagoras' theorem. So let's put in some values. The hypotenuse is always the side opposite the right angle. Opposite to this right angle is the 5. So you could put in that 5 squared is equal to any side. So I'm going to choose this as my first side, 3. So that's going to be 3 squared plus the other side. I'm going to call the length of the other side here x. So that'll be x squared. So 5 squared, if I remove this 3 squared by minus in it on both sides or bring it over and change the sign to minus, right? 5 squared minus 3 squared is going to give me x squared. 5 squared is 25, 3 squared is 9. So 25 take away 9, which is 16, is going to be x squared. So to get x, I have to find square root on both sides, which I did. Square root of x squared is x. Square root of 16, in this case, we select 4. We know it's plus or minus 4, but we're going to select the 4 because the length of a height could only be the height there, right? Or how far it goes up could only be positive. So it's going to be 4 because the square root of 16 here is 4. And that's going to be 4 meters. Answer E. Okay, so that would bring us to the end of this past paper, 2014. I'm going to put the recorded link in the WhatsApp chat so that you could go and review it at your leisure, anyone that's giving you trouble. All right. And the more of these you do, you could do more other than what I am doing if you want. But the more we do, the better we'll get at it. And the more often we'll see the same ones repeating, multiple repetitions. And therefore, when you see it, you'll probably know the answer before you even go to calculate it. Right. And that's the benefit of doing practice. All right. And any questions before we leave?
No, sir, I'm good.
Everybody good there? All right. All right. Good to see you guys come out. I know it's a wet, rainy day, but tomorrow is a holiday. Right. So you should be home tomorrow and relaxing. All right. If any of you guys celebrating Father's Day with your fathers, I hope you have a good Father's Day and that your father enjoys his Father Day. You all do a good job. All right. So I'll see you guys probably Saturday or Sunday. I'll put it out to continue with our tutorials. So we'll be moving on to session 6, right? Where we will continue with our tutorials. All right. So God bless you guys. And I'll see you in the next class.
Okay, sir.
Okay, then. Take care.
Okay, bye, sir.
Okay, bye-bye. Have a good evening.
Same to you.
Okay.